This is Mission Control Houston. Again, the activities of the Expedition 24 crew on board all going smoothly. They're in the early afternoon of their crew day. The team and the onboard crew primarily focusing on science work, but the U.S. crew members are taking a break to take questions from students at the Science Center of Pinellas County in St. Petersburg, Florida. With that, we'll be wrapping up our ISS update, but we'll be resuming on NASA TV with that event coming up in just a few moments. This is Mission Control Houston.
Are you ready for the event? Science Center of Pinellas County, this is Houston. Please call station for a voice check.
And partners also at Bay News 9. Okay. Station, this is Science Center Pinellas County. How do you hear me?
We have you loud and clear aboard the International Space Station. Welcome aboard.
Thank you. This is Joe Cuenco. I'm the director. We appreciate the call today. We have 15 students from 8 schools here. We have a couple hundred in the audience here, and we're very excited to be with you. And I have a special message from a special guest. Sept is here. We'll start out with the first student here.
Hi, I'm Sephie. What do you feel are the most significant accomplishments of the shuttle program, and how do you think the International Space Station will take the space program to the next level?
Very good question, and I think probably the most significant contributions that the space shuttle has made to our space program, and one of those is what we're the machine that we're flying in right now. Giving us the ability to carry heavy payloads and people to space, and to be able to build a platform like this International Space Station. Also, significant contributions of the space shuttle have been other heavy lift experiments that it's carried to orbit, including the Hubble Space Telescope. So, and in the way of, when the space shuttle first came online as our workhorse of our space program, it was unusual because it didn't look like a regular rocket. It was asymmetric in thrust, and for the first time we were going to take a single vehicle and use it as a rocket, and then turn it into a spaceship, and then turn it into a glider, all in 3 different distinct phases of flight, and then reuse it. And that was something that was unheard of back in the early days. And so those are the most significant things that we've learned through the program, and we've been able to build wonderful things and research platforms in space. And now the space station carrying us to the next level. What we're doing now is flying on 6-month long duration missions. And one of the things we're doing in addition to our research that we're doing is we're replicating the distance and the time it would take to travel to another planetary body like Mars or an asteroid or something. And so some of the research that we're doing is the research on the human body to be able to sustain life, sustain systems in this long journey to an outer planetary body, and so that's one of the ways that the space station is going to carry us to the very next level.
Hi, I'm Indigo Nar. Hi, I'm Indigo Nar, and how do you communicate with the robotic arm outside of the space station?
Indigo, flying the arm is much like playing a giant video game. We can communicate via computer commands. I have, when I was flying the robotic arm, I've got 2 hand controllers that I use, one that does translational control and one that does rotational control, as well as a laptop where I can send commands. And so everything that all the inputs I make on the inside are sent via the computer lines to the computer boxes on the arm on the outside, and then the arm performs the motions that I'm requesting it to do.
Hello, my name is Cody Kronz, and I just want to know, can an explosion actually happen in space since there's no oxygen?
Well, if you're just talking about anywhere out in space, you need to have, in anywhere, you need to have three things. You need to have an ignition source, you need to have fuel, and you need to have what's called an oxidizer. And oxygen is an oxidizer, the best one, actually. So I guess if you were to pick anywhere out into space and say, would an explosion happen with no oxygen, unless it had an oxidizer, then I don't know how it would happen. But certainly, if you have oxygen somewhere out in space or here on board the space station, then there is always that potential. And if you're not sure exactly what an oxidizer is, you can just think about those three components: an ignition source and a fuel, and an oxidizer is all three people that want to go to a party and have a great time. And unless you have those three components, then that party isn't going to happen. And when you get into chemistry, you learn more about it there.
Hello, I'm calling Thomas, and I was wondering what research you are conducting in the medical field.
Hi, Colleen. That's a great question because we really have just gotten the laboratories up and running, and we've got over 130 experiments going on board. And a couple of things that I'm working on this week are, one is a look at our diet and salt intake. One of the things that's kind of a spin-off of what we're doing in long duration flight is our skeletal structure and the way that our body leaches calcium out of our bones, and we have decreased bone density in our skeletal system. We can look at how changing a diet can impact that bone loss, and how to maybe stave off things like osteoporosis and things that plague us as people on Earth. And so we actually, being up here for a long period of time, our bodies sort of go into an aging process that with our bone structure that sort of replicates the onset of an older age, and we can do these experiments with diet to see if we can impact that and potentially stave off that type of disease. Also, we're working. I'll be working the next several days on a fluid physics experiment called Marangoni, which is actually looking at creating a liquid bridge as a conduit to transport using just differential temperature with the absence of gravity. We don't have any convection here, and so we're going to look at building a liquid bridge and using temperature differential to try to create convection and look at ways to transport, optimize the transport of material through a medium, and that could project onto pharmaceuticals transporting through the bloodstream, and also energy transporting through a medium on Earth as well, through a power line or something like that. So those are the two things that stand out in my mind this week that we're working on, but we have several experiments that we're working on in the medical field.
Hi, I'm Sarah Graves, and I was wondering, does microgravity have an effect to your internal organs, and if so, what are the effects?
Sarah, it's actually very interesting what happens to our internal organs. For one thing, without gravity, they may shift around a little bit, so they may not be quite in the same position that they are on the ground. But one of the main things that happens that's very important to us, as Doug mentioned, our skeletal system loses density, and so does our muscular system. So we lose muscle mass. And the heart, being an internal organ, but it is also muscle, loses mass. And so our heart actually shrinks while we're up here, which is very important to us when we come back, because we need our heart to work with the same endurance and intensity that it did before. So that's why actually we do a lot of exercise up here to keep our heart healthy and strong, so it's in good shape when we return.
Hi, my name is Jack Scarbo, and my question is, what is the main energy source for the International Space Station?
Well, here on this increment,
it's Wheels whenever he's on the cycle ergometer. But when Wheels goes home, it will be mostly from the sun. We get solar energy that's captured by our gigantic solar arrays that we have on both sides of the space station, and that solar energy gets stored and transferred into electrical energy, electrons. And you have electrical energy in your house, and that's how you power all the appliances and your stereo and your TV and your computer. And that, what I would say, is our main source of energy here on board the space station.
Hello, my name is Andrew Fletcher. Are you doing any research about creating artificial gravity on the space station?
Hi, Andrew. We're not creating artificial gravity, but we do have some things. You know, one of the neat things about doing the science that we do here is we take gravity out of the equation. So wonderful things happen, and we hope that we come across some incredible discoveries when we take gravity out of the equation. But our bodies are used to working and living in gravity, and we want to be able to walk when we go back home. So we don't have an experiment that where we're creating artificial gravity, but we do that on a treadmill by using a harness where we pull ourselves down onto the treadmill to sort of replicate our body weight, so our leg muscles can continue to work and function so we can walk when we get back home. We also have an exercise device where we create resistive exercise to sort of simulate, again, gravity or lifting weights to try to keep our muscles toned and things like that. And we also have a centrifuge on board as well that we use in the creation of our the application of our science. And so we don't have an anti-gravity or gravity room per se. So we're not working on that in particular, but we do try to replicate that when we're doing our workouts and things.
Hello, I'm Denisha, Nisi for short. Are robotics like Robonaut 2 assembled before they go up in space, or is the crew responsible for assembling them once they are on board?
Denisha, the answer is it just depends. Actually, I honestly think that Robonaut 2 is going to be completely assembled when it comes up, but I don't know how it is packaged. Other robots, such as the robotic arms that we have on the outside, the Canadian robotic arm, the large arm, as well as the special purpose dexterous manipulator, they were not assembled, and crews had to do spacewalks to assemble them outside. So it really just depends on how big the robot is, or the robotic apparatus is, because it depends on what kind of storage space it has to fit in on the ship that's bringing it up here.
Hello, I'm Brian Horan. How are robotics being used on the space station? And do you think this will lead to new uses for robotics on Earth?
Well, we have a number of robotic arms, and Shannon just mentioned a few of them. We have a very large robotic arm we call the big arm, the Canadarm2, and it's about, what, 60 feet? About 60 feet long, and it has 7 joints, and it can move in 7 degrees of freedom. So it can do all sorts of things, and it can inchworm its way across the space station. We also have, as Shannon mentioned, the what do you call that? Special purpose dexterous manipulator. We call it SPDM for short, and I like that much better. And it almost looks like a hand with some fingers that can do a lot of intricate work. We also have an arm that's a bit smaller than the Canadarm2 here outside of our Japanese module. And it's used to move pallets along a platform that we have outside, where we're conducting external experiments to understand the space environment better. And we also have little miniature robots that are inside some of our experiment modules inside the lab here, and they're placed inside of equipment racks, some experiment modules to help move samples from place to place. And that's pretty much summarizes all the robotic arms that we have. We also have some other joint systems that are outside that take some manual control in order to operate. But for the most part, there's about four robotic arms in general on the space station. And as far as their new uses on Earth, you know, it's funny that if you think about one of our most common robotic arms on Earth are cranes, and our robotic arms here on Earth, on the space station, mimic very closely a crane. And I'm sure you've seen cranes on Earth as they at construction sites. New uses, well, right now, I think one of the most exciting new uses of robotics is in the medical field. And as we are exploring space and want to go beyond low Earth orbit to other planets, it may become useful for to do surgery or medical procedures on someone remotely, and it could be through the use of small robotic arms, and so that's one of the exciting uses. But it doesn't have to be in outer space. It could also apply to Earth in situations like currently what we have with our Chilean miners. If something were to happen to them, we could potentially have taken a robotic arm down that small tube and performed a procedure on someone if we didn't have the right expertise down in the mine with them. That's just an example, say, of how the robotic uses on orbit here can maybe be led to new uses on Earth. But that's a great question.
Hi, I'm Spencer, and what is the hardest challenge you face with the robotics in the space program?
Spencer, great question. Well, for me, I think it's just control touch and learning. You want the robot to be an extension of your arms and your hands itself, and so that's probably the hardest part for me personally is in learning to operate the arms, is just to understand the control laws of how the thing is operating, and then try to mimic that with my own hands and arms, and be able to decipher that in my mind to make sure that you don't get. If you've been working with robots, I understand, and so you understand when you're out of phase with the control laws of your robot, and you can get into an oscillation that tends to get worse as you try to over control. So just control touch and control laws are probably the biggest challenge for me. And I felt very fortunate when I was outside doing a spacewalk, when Tracy and I went outside, that I was on the end of the robotic arm, and I felt very, very fortunate that Shannon was in control of the robotic arm when I was out there. So so I've been on the other end of it, where someone who really knows what they're doing with the robotics is in control, and it's very, very smooth. So that's a great question, Spencer.
Hi, I'm Chris Olenis. Can you see the oil spill in the Gulf of Mexico?
Actually, we can, or we could, when it was there. If we flew over the Gulf during the right time of day, so the sunlight was just right, and not at night, of course, we could see the oil on the surface of the Gulf of Mexico there. It was quite a sight to see.
Hi, I'm Hillary, and what types of radiation do you monitor, and what do you do to protect yourself from it?
Oh, wow, that's a big question. I think the main source of is X-rays, and we also monitor whenever we have solar flares, mostly solar particles that that may come our way. We have a number of ways to monitor radiation exposure. We have a unit that we have inside the module that is a detector, and it collects any particles that come in, and it counts them and gives us a reading. So that takes care of what our environment is exposed to inside the space station. But each of us have what's called a dosimeter, and it's a small little chip that we carry in our pocket, and we keep it on us at all times since the moment we launched into space till the moment that we land. And we're going to have this little chip, and then we hand it to the smart people who know how to read them, and they collect all the data, and they can calculate how much exposure we've had since we've been in space. And then we also have some smaller dosimeters that actually we've used from our Russian colleagues that we took out on our spacewalk with us. And those actually you can read immediately. So we were able to get information on how much radiation we received once we went out onto our spacewalk and came back in. And that was very helpful. And can't think of any other forms. Oh, yes. We also have radiation protection. We call them radiation bricks, and they are lining our crew quarters. We each have a little bedroom, if you will, a box that we sleep in, and we have the inside lined with these bricks, and they help to shield radiation that would perhaps come through the walls of the space station. So I think that gives you a pretty good idea of how we monitor radiation and the types of radiation that we're concerned about.
Hi, my name is Jonalyn Gordon, and what resources are available on the space station to track the dispersal of the oil spill and the effectiveness of the cleanup process?
So I'm not sure I heard your question entirely, but it was what resources do we have to track the dispersal of the oil in the Gulf of Mexico? Well, mostly what we have up here is just visual. We can, and cameras, so we can look with our eyes and see where we see the oil going, and we can take pictures, which is actually very helpful for the folks on the ground to see how the oil is dispersing. Anything under the surface of the water, we cannot detect from up here. We don't have the proper equipment to detect that from up here.
Hi, I'm Mallory. Can you hear or feel the sonic boom on launch or re-entry?
That's a good question. I've only been re-entered the atmosphere one time on the space shuttle back a few years ago, and I was not able to feel or hear the sonic boom. You can feel different stages of the re-entry in the way of vibration, sort of lateral vibration and sometimes a longitudinal vibration, and so you can't hear the sonic boom, and definitely can't hear it during the launch sequence because of the other noises going on around you. So. And the vibration as well. So I'll have to say that I've launched one time on the space shuttle now and one time on the Soyuz rocket, and the space shuttle in the first stage, and I think probably some of it's because of the asymmetry that you're actually sitting a little bit displaced from the center of thrust. The vibration is fairly a lot greater than in the Soyuz rocket, but you can't hear the sonic boom.
Space Station, we really appreciate this. It's been an awesome Teaching from Space partnership, and NASA Education, the Science Center. We really appreciate that. Thank you so much, and God bless you. Godspeed.
Thank you very much. And those questions were wonderful, by the way.
Okay. As far as my
station, this is Houston ACR. That concludes the event. Thank you.
And thanks to the Science Center of Pinellas County station, we are now resuming normal audio communications.